Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic that sounds super complex, but is actually all around us, shaping our world in incredible ways. We're talking about nuclear physics. So, what is it? Simply put, it's the science of the atomic nucleus, that tiny, dense core at the center of every atom. It's about understanding the building blocks of matter itself, protons and neutrons, and the powerful forces that hold them together. Forget what you think you know from sci-fi movies. The real story of the nucleus is way more fascinating. Stick around, because we're about to unlock the secrets of the atom's heart. First, let's break down the core concepts. Imagine the nucleus as a super-packed little ball of protons and neutrons. Protons have a positive charge, and normally, positive charges would push each other apart, right? So, what stops the nucleus from just flying apart? The answer is the strong nuclear force. It's one of the four fundamental forces of nature, and over very short distances, it's incredibly powerful, acting like a cosmic superglue holding the nucleus together. But sometimes, a nucleus can be unstable. It might have too many neutrons or protons, and it wants to find a more stable state. This is where radioactivity comes in. An unstable nucleus will spontaneously transform, releasing energy in the form of radiation, like alpha, beta, or gamma rays. This process is called radioactive decay. It's a completely natural phenomenon that happens all the time in rocks, in the air, and even in our own body. Now, let's talk about nuclear reactions. This is where things get really energetic. There are two main types: fission and fusion. Fission is when a heavy, unstable nucleus, like uranium-235, splits into two smaller nuclei when it's hit by a neutron. This split releases a huge amount of energy and more neutrons, which can then go on to split other nuclei, creating a chain reaction. This is the principle behind nuclear power plants. On the other side, we have a fusion. Fusion is the exact opposite. It's when two light nuclei, like hydrogen isotopes, are forced together under extreme temperature and pressure to form a heavier nucleus. This process releases even more energy than fission. In fact, fusion is the engine that powers our sun and all the stars in the universe. Scientists on Earth are working hard to replicate this process to create clean, virtually limitless energy. So, how does all this mind-bending science affect our daily lives? You'd be surprised. The most well-known application is nuclear energy. Nuclear power plants use controlled fission reactions to generate electricity, providing a significant portion of the world's power without producing greenhouse gases. But that's just the tip of the iceberg. In medicine, nuclear physics is a lifesaver. PET scans, or positron emission tomography, use radioactive tracers to create detailed 3D images of what's happening inside your body, helping doctors diagnose diseases like cancer. Radiation therapy uses targeted beams of radiation to destroy cancer cells with incredible precision. Beyond medicine, nuclear techniques are used in everything from carbon dating ancient artifacts to sterilizing medical equipment, inspecting industrial materials for flaws, and even in agriculture to create more resilient crops. It's an invisible technology that has a visible, positive impact all around us. So, to wrap it all up, nuclear physics isn't just about bombs or complicated equations. It's a fundamental science that helps us understand the very fabric of our universe. From the strong force holding matter together to the radioactive decay that helps us date history, and the powerful reactions that light up our stars and power our cities. The atomic nucleus is a source of incredible potential. As we look to the future, the field continues to evolve. Scientists are pushing the boundaries to develop safer nuclear reactors, harness the power of fusion for clean energy, and create new medical treatments that were once thought impossible. It's a field filled with challenges, but also immense promise for a better, more sustainable future. The journey into the atom's core has only just begun. Thanks for watching. If you found this journey into the nucleus as exciting as I did, make sure to hit that like button, subscribe, and ring the bell so you don't miss our next adventure. See you in the next video.